Okay, in this video we're going to write some polynomial equations. We're going to do number 4 really quickly and then move into number 5 on this video. So, looking at number 4, we want to write an equation that has, some form y equals, what does y equal? Okay, and that's always our goal. That, if you look at number 5, when x is 0, y is 3. When x is 1, y is 2. Well, if x and y are related, what is it about that relationship that makes y be 3 when x is 0? What is it about the relationship that makes y be negative 2 when x is 1? We're going to do the same thing up here. These are our y values, right? So what is the y value? Negative 7. Does it ever change? No. Y is negative 7. That is the equation. Okay, let me do, that's a constant equation. Okay? It's just a horizontal line. And the reason for that is, what's the difference between these? Nothing. There is no difference. It is constant. Y is always 0. It doesn't matter what x is. That's why you don't see an x in this equation. X could be 1,000,000. Y is still going to be negative 7. Okay, but what if we said, okay, the first difference they have in common? Then we know from the last video that that would mean 0 was a in this equation. So we'd be saying, okay, it's linear because the first difference is what they have in common. So y equals ax plus b, and a is 0. Y equals 0x plus b. Well, what is 0x? Well, let's not even bother writing it if it's nothing. So y is just equal to b, and what is b? The y-intercept. Okay, so another way to do it would be to take any point and plug it in. So 2, negative 7. When x is 2, y is negative 7. So in this equation, when you come to y, you plug in negative 7. When you come to x, you plug in 2. But you don't have an x. So you could just come out with this statement. Negative 7 is b. And so that's why you write the equation y equals negative 7. Okay? It's an easy thing, but if you're just caught in this mindset that I have to find the differences and you're just doing a procedural thing, then it makes it hard. And we got to understand what we're doing and why. Okay, speaking of why, I don't know why that's not a good segue. We're going to do number 5. So first step, let's find out what kind of function we're dealing with. What kind of polynomial is this? Okay. So we got to do some subtraction. 67 minus 30, 37. 30 minus 7, 23. 7 minus negative 2, 9. Negative 2 minus 3. 3 minus 22 is negative 19. And then, okay, so since those aren't in common, it's not linear. So then we do 37 minus 23, that's 14. 23 minus 9, 14, 14, 14. They're all 14. Okay. Second difference is what these things have in common. So it is a quadratic function. Quadratic polynomial. Okay. Quadratic polynomials can all be written in this form. Y equals ax squared plus bx plus c. All right, start with an x squared. Use every exponent on your way down, and the coefficients, you just use the alphabet, a, b, c. Right. And one of these could be 0. Like if b is 0, then we just don't have an x term, and it's a quadratic binomial instead of a trinomial. All right, so what do we know about that equation? We know some of these letters, actually. So x and y are always going to stay, but we know a and we also know c. C comes from here, the y-intercept. When x is 0, both of these terms go away, and you're left with only c. So since y is 3, c has to be 3. C equals 3. And from over here, from the common difference, we can find out what a is. Remember, if it's quadratic, then the common difference is equal to 2 times the value of a. And so I get a equals 7. All right, so we'll replace a little bit over here in our equation. Y equals 7x squared plus bx plus 3. Only got one thing left. One variable in the middle that I need to know, b. The way you find the last ones, so if it's quadratic, you'll have one left to find. If it's cubic, you'll have two. Quartic, you'll have three, and so on. So if you have one thing left to find, you need 1 point from this list. And I highly recommend choosing the value when x is 1, choosing that one. And what you're going to do is take that point, 1 comma negative 2, and plug it in. Okay, so if the y value is 1, or is negative 2, the x values are 1. So you get negative 2 equals 7 times 1 squared plus b times 1 plus 3. Every time I came to an x, I wrote 1. Every time I came to a y, I wrote negative 2. b has to have a value to make this a true statement. If it doesn't, then this isn't a function, or this isn't the function that models that data. And the reason I choose the value, the point, the ordered pair when x is 1 is because it simplifies to what I have in blue here, just without the x's, without the x squared and the x. So it's easy. 7 plus 3 is 10. And I'm going to subtract 10 from both sides, and I get negative 12 equals b. So you come all the way back up here, and now I know a is 7, so 7x squared minus 12x plus 3. So real quick, what I did, I want to just show you something that's a really powerful tool, and I'll probably make a video where I show you how to do this. If you hit stat and go to edit, stat and edit, you can put these points in. List 1 here, I put all the x values. List 2, I put all the y values. Go to y equals, you see where it says plot 1. If you go up there and you hit enter, it'll turn it on or make it shaded black. And I'll hit graph. Look at that thing. Doesn't that look quadratic? Okay. My function should go through those points if my function models this data correctly. So let's put it in and try it. 7x squared minus 12x, whoopsie, sorry, I'm dealing with computer problems, plus 3. You hit graph. Look how perfect that is. So beautiful. So we know that our function's correct because it goes through all those data points. And that's it. We'll pick back up with a cubic function on the back.